Hello everyone, myself Hemant Pandey from the Department of the Computer Engineering from Praveen Patil Polytechnic College. Okay, so we are doing the topic basic mechatronics system. In the last few lectures we have seen the introduction to the mechatronics, then block diagram, one example, what are the benefits of the mechatronics systems, and most importantly the difference between traditional and mechatronics approach. So till here now we get the clear concept that what is actually the mechatronics system, okay, and what are the benefits of the mechatronics system, right, and what is the basic principle of the mechatronic system. Now let us see, because in the mechatronic system the most important is the control system, right? So for the control system we have two things. We have two systems. One is a open loop system and second one is a closed loop system. Okay. So from the diagram you can clearly see what do you mean by the open loop system and what do you mean by the closed loop system. So it is very simple. Okay. In next few minutes we will get clearly the understanding of what is open and closed loop system. Okay. So both these systems are from the control system. Okay. So let's see what do you mean by open loop system. So there's a one process, right? Process means here process means anything, right? Anything which convert from input to output. Okay. So what happens in open loop system? In open loop system there is no relation between output and input, right? We are giving the input and we are getting the output. That is a simple definition of an open loop system. Okay. Sorry. That is simple example of an open loop system, right? But what happens in a closed loop system? In a closed loop system, we are giving input and we are getting output, and from that output we are feeding back that output signal to the input. And why we are doing so? Let's understand by one example. Okay. So let us see the best example for open loop system is, because let's see the example of a traffic signal. Okay, now what happens in the traffic signal? Traffic system controls the traffic signal of the vehicles on the road, right? Now how it control, right? It doesn't have to worry about the traffic means length of the traffic jam, right? It doesn't have to worry about that. What happens? It opens the green signal for a few seconds, for few minutes or 1 minute, for all the side, right? Suppose it is a junction, so for all the four side it will open 1 minute for everyone, right? It doesn't have to concern about output, that what is the output, whether this road has a less traffic or that road has a less traffic. It doesn't have to worry about that. So that is an open loop system, right? We are just controlling the traffic signal without using any feedback system. Okay, we don't have to see that which road has a more traffic, then we have to give the green light to that road for the maximum time as comparing to the rest of the three. Okay, so that is an open loop system. I will give you more example during the differences, but just for understanding, just focus on the traffic signal, right? So that system is also one type of control system, because here we are controlling the signal, controlling the traffic jam, and that is the best example of the open loop system, right? We are giving the input and we are getting the output. Okay, we don't have to measure any output, that what is the length of the traffic jam or which road is more empty. We don't have to worry about that. We just have to give the input. Okay. Now let us see what do you mean by closed loop system. In a closed loop system, what happens? We give the input and we get the output, and we have to measure that output so that we can control. The best example here, we have seen this here, right? We have seen this here example. This is nothing but a closed loop signal, right? See, this controller, motor and DC, this comes under your process, right? And this is your output, and this output is again given to the input. So this is a closed loop system, right? So here we have to see what is output, right? For example, as I told you, suppose the speed is 1000 rpm and we have to increase it to the 1200 rpm. So we have to constantly measure that output, and depend on that output we have to give the signal to the controller. Means we are taking the output and we are giving back it to the input. So we are measuring that signal constantly, right? So this is the example of the closed loop system, right? I hope you understood what you mean by closed loop and what do you mean by open loop. In open loop we don't have to worry about the output, but in the closed loop we have to worry, right? Okay. One more example, okay, I am giving you right now is fan. Fan is an open loop system. We just on the fan and we get the air, right? We are not controlling anything. We are not controlling the output. It is a simple process. But what happen in AC? In AC, suppose we are keeping the temperature of 24, right? So what will happen? It will cool the room till 24 and it is constantly measure the temperature of the room. And as soon as the temperature reaches to 24, it stops, right? Or it slow down the compressor, right? So that no more cooling is required for after 24 degrees Celsius, right? So that is a closed loop system, right? Because we have to measure the output. What is the output? And for that output, by measuring that output, we give signal to the control. In the case of the AC, we give signal to the compressor. Okay. So that is a closed loop system. Okay. So this is the basic difference between open loop system and closed loop system. So what are the basic elements of the closed loop control system? Right, so we can see that input, right? What do you mean by input? Input is nothing but a stimulus or excitation signal applied to a control system from an external source, usually in order to produce a specific response from the system. Okay, so some words are a little bit difficult, but it is nothing to worry about it. It is a simple signal which is given to the system, to the process, so that we get the some output, right? A response, nothing but output. A specified response from the system means some output from the system. That's it. Okay. And excitation signal means the signal which makes some changes, right? Which excited something. Output, the actual response obtained from the system, right? Whatever we are getting from the, suppose we are switch on the fan, so we are getting air, so that air is our output. Okay. Okay, next one is feedback. Okay, so as we are understood that one, we have seen last few example, that one DC motor speed control and second one was air conditioner. What do you mean by feedback? That portion of the output of a system that is returned to modify the input and thus served as a performance monitor for the system. Okay, so what do you mean by feedback signal? Right? We use the feedback signal for the monitoring purpose, right? We regularly take a signal from the output and give back to the input. Why? Just to monitor, just to track. Why to track? Because we need some specific goal, right? In the case of the air conditioner, we need 24 degrees Celsius. So what is our ultimate goal? That we have to maintain that temperature. And how we can maintain that temperature? By constantly measuring the output. Okay. And by measuring the output, we will give that signal to feedback. Okay. Now what do you mean by error? Okay. So error is nothing but the difference between the input and the output response. Right. Specifically, it is a difference between the input and the feedback. So I will tell you in this example. Okay, as I told you here, suppose we need 1200 rpm, right? And right now the motor is running on 1000 rpm. So the signal here is 1000 rpm, right? But signal we want here is 1200 rpm. So what will happen? This signal will come here, that is 1000 rpm, and the 1200 rpm is here. So what we are getting the error? We are getting the error of plus 200, right? So what do you mean by plus 200 error means? What is the difference between actual speed, that is output, and input? Input we have given 1200. but output we are getting 1000, right? So 1200 minus 1000 is 200. So we want 200 RPM more. So that is your error signal, right? So because if okay, now we'll increase the speed of the motor, and at one time what will be the speed? 1200, right? So we are getting output as 1200 and the input is also 1200, right? So at that time what will be your error signal? 0, right? Because the input minus output or output minus input is equal to error signal. So here we are getting 0. It means now we do not require any extra command because we already got our actual speed, right? In the same case of the air conditioner, what will be the error signal? Suppose I need 24 degrees Celsius and the temperature of the room is 28 degrees Celsius. So we are getting 28 minus 24, that is 4 degrees Celsius, right? So that is your error signal. It means you have to increase the compressor till to make that 4 degrees Celsius to 0, right? That the difference of that 4 you have to give it to the 0, right? So that is why we need this. So this is nothing but your error signal. Okay, fine. So this is the basic elements of the closed loop control system. Okay, so these are the different elements which use in the closed loop control system. Okay, so one more important thing, difference between open and closed loop system. So as we have seen that in an open loop system the feedback element is absent, but in the closed loop system is it present. There is no error detector, right? Because there is no error signal, right? Since there is a no feedback signal, there is a no error signal. So there is no error detector is present in open loop, but in closed loop error detector is present. It is a stable one, right? Open loop system is a stable one. Why? Because it doesn't have to worry about the output. It is very stable. But closed loop systems sometimes becomes unstable, right? When output is not in control, we have to do in control. So that's why system becomes little bit unstable. Open loop system easy to construct, right? Because there is a no feedback system, so it is very simple. But in a closed loop it is a complicated construction. Open loop is a economical. As I told you, there is a no feedback signal, there is a no error signal, there is a no error detector. So that is why that open loop control system becomes economical, that is less cost. Closed loop system is costly. Open loop is inaccurate. Why? Because we don't control the output, right? But in the closed loop system we control the output, so that is why it is more accurate. Less maintenance in open loop system. Closed loop system there is a more maintenance. Unreliable. Open loop system is unreliable. Closed loop system is reliable. Example, hand dryer, tea maker, right? So all these things are open loop system, right? We heat in a tea maker, it's heated for 10 to 15 or 20, 30, 40, whatever the time, right? You don't have to see whether tea is ready or not. It's just heated for the 15 or 1 minute or 2 minutes, right? You don't have to see about the condition of that tea, right? So that is an open loop system. Example for the closed loop system is automatic door, robots, right? Automatic door means the door is opening and closing automatically without any human intervention, right? So that is a best example for the closed loop control system. Okay, so we stop here, and with this the first chapter is completed. Okay, so thank you guys. If there will be any doubt, we will solve it in the live session. Okay, thank you.